previous lesson, and I'm actually going to write this formula again for you, I gave you this formula for the effective interest rate. And what the effective interest rate does is it calculates the effect of different compounding intervals and summarizes them into one yearly rate. So the idea behind this is if you chop up your interest rate periods into quarters, then the effective interest rate would be different than if you had it per year, because of the effect of compound interest, that you get interest on interest. And so what this formula does is it allows us to take into account the effects of different compounding periods. Sounds like a bit of a mouthful. It's not really that bad, but let me show you the formula. So the formula is that where M is the compounding period. So a common question would be this: what is the effective interest rate if 7.5% per annum, if interest is calculated at 7.5% per annum, compounded monthly? So compounded monthly. See if you can work out what the effective interest rate is for that. And then we'll go from there. Hey, David. Yeah, I see a question from Sylvanus, is it? Sylvanus, I'm going to unmute you and then go from there. Can you hear me, Sylvanus?
Yes.
Hey, how's it going?
Good, and you?
Very good, thanks. What can I help you with?
For the question, it says, what is the effective interest rate is 7.5% per annum is compounded monthly. What do they mean by compounded monthly?
They mean that, okay, so if 7.5% per annum is compounded monthly, basically what the question is saying is it's saying the nominal rate is 7.5% per annum, per year. And the effective rate, if your nominal rate per year is 7.5, but you chop it up into smaller chunks, into monthly chunks, the effective rate should end up being higher. And so what we do is we are trying to take into account how much more interest we get when we chop the compounding periods into smaller intervals. So what number, Sylvanus, do you think goes with compounded monthly? What do you think we have to divide a year by to get it into months?
Would it be 12?
Yeah, exactly. So all we have to do is we replace those two values with 12, and then we put this interest rate, 7.5% per annum, but that's, we need it as a decimal. And so we take 7.5 and we divide it by 100, and it ends up being that. So this will give us the effective interest rate. And that's what I want to see in the chat from students. What are we getting for that amount? I'll give a little bit of time there. So the effective rate, you should get 7.76% based on what. Now, what you notice is that the effective rate, the effective interest rate, is higher than the quoted nominal interest rate, because that was 7.5 to deal with. And that's because when you chop it up into a month, and after the first month, you get some interest. And then you get, in the second month, you get interest on the original and the bit that you added. You end up getting more interest at the end of the month. And I'm going to show you this. Let's adjust this question very slightly. Instead of saying 7.5% compounded monthly, I want you to now work out what the effective interest rate is if it's quarterly. So same as before, except now you're changing the compounding period to quarterly. And I want to see, can you work out what the effective interest rate is if you start with the same nominal interest rate, but you're going to break it up into quarters now. What would that look like? I'll have to get my calculator out for this one. So I'm getting 7.71%. Can you see that the effective interest rate when you compound per quarter is lower than the effective interest rate when you compound per month? Give me a thumbs up if you see that. Like the pink one is bigger than the green one. Can you see the pink one is bigger? And the reason the effective rate is higher is because you've chopped it up into smaller pieces. And so you've got more interest on interest. Okay. So the good news is this nominal effective interest rate thing is really nothing more than converting between formulas and knowing how to do that. And then knowing what the effective rate does is it basically sums up the effect of compounding to an effective yearly rate. Okay, let's move on from there. I don't think there's too much more. I think you guys have shown me that you know what's cooking there. Well, let's do, okay, I tell you what, let's do this question, but we're going to do a bit of a remix here. So it says here that Corsi wants to invest 5,000 for 3 years. And it says, what is the better investment? If the interest rate is 10.5% compounded quarterly, or if it's 10.5% compounded monthly. Now, I don't want you to, okay, there's a couple of ways you could do this. The one way of doing it is to literally use the whole formula. So you can take this formula, which is the compound growth formula, and you can calculate for each of these scenarios what value you would get, right? So you can go 5,000, 1 plus, and then the 1 is going to be compounded quarterly. So 105 divided by 4. So that would be the one possibility. And then
the meeting could
give me a second. I'll explain now what I'm doing. 3 times. So I know that I've done most of the working on this, but I just want to actually show you something more than get you to work it out, because I know you can probably do this. Give me a thumbs up if you understand my working for what's going on here. I'm comparing the two interest rates. Okay. Now, if we have to get answers for these two values, this was the per quarter. So I'll put Q, and this one is per month. Get me a value for each of these. Get me a value for each of these. Yeah, Lesego, let's go to you. What's your question?
Forgive me for not understanding completely, but why is it with the interest and the time period? I understand why you multiply the time period, but why is it that the interest is divided? Because that's not what that or specifically this formula doesn't necessarily say compound according to that method. It just says.
So the nominal rate is 10.5% per annum, right? So that's the quoted basic rate. Yeah. If you want a quarterly interest rate from a yearly interest rate, you have to divide it by 4. That will give you an interest rate per quarter. And then you say, how many quarters are there in 3 years? That's why you've got the 3 times 4. Right? So that's the relationship between that. And for the same reason, this is divided by 12, and then this becomes times by 12.
Oh, so when they say something percent per annum compounded quarterly or compounded monthly, then you have to do that.
Yes, you do. Yeah.
But if they just say something percent compounded quarterly, then you can just leave it as is.
They would have to say to you, this is the quarterly interest rate. But normally they're almost always, they give you the yearly interest rate, what's called the nominal rate, and you have to chop it up.
All right.
So
all right.
If we look at the answers we should be getting, I'm just going to sneak here and use my thing. You should be getting 6823.51. And then for the second one, you should get 6841.92.
Okay, thank you, sir.
Okay, so out of those 2 options, which of the 2 do you think is better? Which is the investment that you would prefer to have? Would it be the Q or the M? Okay, it would clearly be the M because you end up with more money, right? 6, you end up with more money. Now, the thing is, the effective interest rate is higher when you chop it up into a monthly period than if you chop it up into a quarterly period. Can you see the connection to the first question of today where I showed you that the effective rate was higher? Let me just go back for a second. The pink one was higher because you were chopping it up into months, whereas the green one was chopped up into quarters. And so if we had to work out the effective interest rate for each of these 2 options, the monthly one would have a higher effective rate. And that's why you end up with a higher amount of money. I don't know if I'm losing some of you there, but I'm just trying to show you that basically, if you chop up your interest rate into smaller intervals, then when you compound it, you end up with more money or a higher effective rate because of the interest on interest idea. Okay. Thumbs up if you get that. Thumbs down if you're unsure or feeling a bit like you want more clarification, or put your hand up and then we can go from there. All right, then let us go to a different type of question. Let us go to a different type of question. So a common type of question that happens in the section is sometimes what they call a timeline question, where you change the interest rate and the time periods in a question. And so I just want you to take a little bit of time to read this question. And then I want to ask you, what are some important time periods in this question? So take 30 seconds. And then in the chat, I want you to tell me, as you think of this journey, what are some of the important points along the journey? What was the answer to number 2, Dawn? I'll put it there for a second. Okay, so take some time to read this question. Tabo invested in a bank for 10 years, a certain amount of money. What are some important points along the timeline of this situation? And I'd love for somebody to either come online or to put it in the chat. Yeah. Fagelo, let's go to you. What do you think are some important points along this journey?
Okay, morning. I mean, no, sorry. Hi, everyone. We have the original amount, which is the
Yes.
1,000, which goes to
Okay.
T0. Okay.
Okay.
Then we have the interest rate that was compounded quarterly for the first 3 years.
Aha. So would you say that T3 would be an important point on the timeline? Do you agree
Yes.
T3 is like important? Okay, so I'm going to put
Yeah.
that there. Okay, what do you think's next is important?
So on the timeline, then we're gonna count the next 5 years, which will
Yeah.
then be 7.2, and it's compounded monthly.
Okay. So what I'm going to say, you said the next 5 years. So would you agree with me that T8 would be another
T8.
important point? Okay.
Yeah.
So if we think of this story, there's a lot of text and information. What I like to think about is what are some important points along the journey? And then the last important point, thanks Fagelo, is T10. Okay, so now this is only half the story, but at least we've got the basic idea of what's going on. Now, the other thing is, and you can do this in different orders, but basically I like to go, well, how much money is in the kitty? Like how much, it's 1,000 Rand, right? At the very beginning. And this 1,000 Rand has to go through a journey over this timeline. And along this journey, the interest rates change. So the interest rate was 6.5% compounded quarterly for the first 3 years. So what I'm going to do is I'm going to write 0.0, oh, let me not. So 0.065 divided by 4, because it's in quarters. Okay, so that was the first bit. And then the journey changes for the next 5 years. The interest rate is compounded monthly. So I'm going 0.072. Notice how it's going to decimal notation. And because it's compounded monthly, I divide by 12. Okay, so I've done that bit, which is good. And then the remainder of the time, the interest rate is compounded semi-annually, which is divided by 2. Okay, so all I'm doing is storytelling at this stage. I haven't done any maths yet, but I think I've told a good story because it looks a lot easier to see what's going on with my diagram than what was going on in the text. Give me a thumbs up if you understand what the drawing is saying. I just want to make sure I've got you all here. Okay, so now this 1,000 Rand needs to go on a growth journey, and it needs to journey from here to here, and then it needs to journey from here to here, and oh, I do like my colors, and then from here to here. However, I need to know what formula am I going to be using to go on this journey. So we haven't spoken about this, and I just want to make sure that what is the formula, the actual mathematics now is coming into it. What formula are we going to use? And you can raise your hand and answer, or you can put it in the chat.
Mr. Ace.
Yeah.
David is asking if you can please repeat how you got that breakdown for the timeline.
Okay, so David, the way I would describe it is I looked for important points along the journey, and I did my T0, T3, T8, and T10 because they were important points on the journey. And then I went and did my squiggly lines to show my interest rate compounding intervals. And so that was my squiggly lines. And then the plus 1,000 is the amount that has to grow. The colorful pink, green, and yellow is just for my own. You didn't have to do that. I mean, but like I'm just sort of trying to make it as clear as possible. Okay. I think that this is the formula that I'm going to use. This is the compound growth formula because it's growing. And the question is asking us, how much money does Thabo get at the end of the investment? So I want to know, if I'm Thabo, what happens when I get to here? How much money do I have? And hopefully it's more than 1,000. Okay, so this is what we do. This first one, I'm going to do it mainly, and then you're going to do the next one. I take this formula and I start with 1,000, and to grow through the pink bit, I'm going to say that was my interest rate. But now the problem I have is this is 3 years and it's broken up into quarters. And so instead of having, what you need to do here is you take your 3 and you times it by 4 and you get 12. And that will get me from the 1,000 from there up to here. Again, give me a thumbs up if you understand what I've done there to go from over here to get to there. The maths is below that. Okay, so now the problem is I'm not finished on my journey. I have to keep going. And in order to keep going, I need to keep growing through here. And what I'm going to pretend is that this bit over here is like a p-value. It's like the 1,000 that I had at the very beginning. I'm just going to think of it as one thing, and it's feeding into my next piece of the journey. So my next piece of the journey is just a multiplication, and it's 1 plus. Now, what is this number over here going to be? That's what I want to know from the people of the room. What's this going to be? If you look at my journey, it's the green part of the journey. Right? It's 5 years, but the compounding interval is monthly. So because it's like I'm breaking up 5 years into months, and so how many months are there in 5 years? It's just going to be 5 times 12 or 60. Yeah, I agree, Tony and Shamila, I agree. So now I've got to here, and I'm still not done. I've still got to journey for this last bit. Now, what I want is I want you to try and figure out what this last bit is, and then try and figure out what the final answer is. So I'm handing over the reins to you. I want you to see if you can figure out what this last bit of the journey is, and then the final answer after that. But I'll give you some time. I'm going to get some water while you work on that. Okay, who has some? So I was thinking 1 plus. So what do we get for my final answer? So you have to be pretty good with your calculator. I think I've got the answers down here. So let's. So the answer, I'm going to cheat. It's 2024. So 2024.64 rands. Okay, now, are there any questions? Because we're going to have a break in a moment, but then after the break, we come back. I'm going to let you guys have a go at one. And I just want to make sure the basic idea is there with you. Why 4? Okay, so Katlego, if you look at the yellow bit, you're right, it's only 2 years, but the compounding interval is half year or semi-annually, every 6 months. So how many groups of 6 months or semi-annuals are there in 2 years? There's 4. And so what you do, I should have actually written 2 times 2, because actually I start with the 2 years and then I multiply by how many, what the number is for compounding. So 2 times 2, which is 4. And I get that answer. So are there any questions before we have our break, guys and girls? Sylvanus, let's unmute you. What's your question?
Must we always round off to 2 decimal?
Okay, so generally speaking, you would round off to 2 decimal places. Sometimes in exams they say 1, but normally the standard is 2. And normally in financial maths, you only round at the end. That's why it's helpful to have this whole chain over here. It's not, you can do it piece by piece, but it just takes a long time, and I would recommend this method. Now, all right, it is time for some stretching. So what I want to see is the people of the class forgetting about maths, and I want to see you standing up, turn your camera on, and let us just be humans together. Stand up, stretch.
Come on, guys, please put your cameras on. We'd love to see your faces. Give your body a stretch.
Oh, that is so good. This is some serious brain work. This whole like timeline thing, you really have to do drawings and you have to follow the maths. So give your body a chance to just relax a little bit. Oh, that was a good click. I love it. Oh, you guys are much more supple than me. I can see some of you stretching and it's like, I can see you can like literally bend right over. Oh. Shake it out.
Shout out to Lesego, Pegelo, not dying to stretch with us.
Tell your teachers, mandatory stretching breaks. Okay, let's do a quick brain break, old school brain break. I want to know, what is a red sweet plus a pink sweet times a blue sweet? What can you work out there? To make sure my okay, so blue is definitely 3. So to say to you, I'm with you all the way. So there's 2 lots of 3 here. What's the next thing we can get? Or maybe I should just wait a little bit and see what class. What's the pink is, okay, so from what I can see in the chat, red is 1. Thanks, Asetu. So that's 1, 1, 1. And then Loretta said 4 for the pink ones. I agree, because 4 times 4 times 1 gives me 16. So I have that. So what is the final thing going to be? Now, I want to remind you of something very important called BODMAS or PEMDAS. It talks about the order of operations. So if you look at this statement, at the moment, it looks to me like 1 plus 4 times 3. And what's that going to end up being? Aha, yes, Sinclair. So say to Loretta. Forgetto. I agree. For me, the answer is 13.
Nicely done,
Sheila,
guys.
Aaron, I love it. This is a good old school question. When we first started doing this, this was like our go-to brain break, these types of questions. Okay. Nicely done. Before we get going with the next part, just shake it out. I'm going to stand up one more time just to let my body unwind. I suggest you do the same. And then let us go to an old exam question. So let's focus for a moment on we're going to ignore the top bit of the examiner question, and we're going to look at 4.3. And what I want you to do is I'll break it up into steps for you. So I'm going to let you do this by yourself, but the first step is I want you to draw the timeline and think about important moments on the timeline. Then I want you to think about the interest rate, and then I want you to think about the amount of money and how it grows. And I'm going to let you try and start, and then you can ask me questions as you go. Okay, so 4.3, and you're given this amount to start with, and I want to know the answer to this. I'm happy to answer questions if you need to, but I think the last bit, it's good to push you to try and do this based on what you remember from the question before the break. Aha. So this is a good question. So I would change 18 months to be in terms of the year scale. So because you're working in years, I would turn 18 months into years. And for me, that would be T1.5. Because it gets very confusing if these are in different bases. So I would say the year base is probably the simplest one to go with. And so 18 months is a year and a half. You often have to do this in financial maths. You have to kind of go between like how many months in a year, how many quarters in this period. So Shoshana, I hope that that helps you a little bit. Mhm. To If you're able to get an answer here, or if you have a question, don't be afraid to ask it in the chat. Or if you feel comfortable, put your answer in the chat, we can see. Hmm. Oh, wait, I need to put my interest rate on here. So 0.09 divided by 2. Okay, so for me, and so then I've got 3.5 times 12. I mean, that's the same as saying this. Hmm, 42. Yeah. Okay. Are there questions about, I haven't figured out the answer yet, but I'm looking at the chats and there's lots of people who are getting the same answer, which I suspect means we're onto something. Let me see if I check that. 27.55, yeah. Okay. So that looks okay to me. Comments, questions, thumbs up if you feel good, or otherwise hands up if you want to ask a question. Okay. So what I'm going to do is I'm going to move on because I think it's good to get a bit more practice on this. But I like what I'm seeing. If I look at the questions above, both of these questions we've covered in the previous lesson. So I'm going to leave them for now because I feel like you've had practice with them. And so let's just move on to another exam question where we can practice this again. Okay, just very quickly. Can you do 7.1 for me? So 7.1 is not a timeline question, it's a different question. And then after you've done 7.1, we're going to do 7.3, which is a timeline question. So 7.1, see how that goes, and then we'll do 7.3. See if you, yeah, let's try and do those two. I like to mix it up because now as you're getting stronger at this, yeah, Lesego, let's go to your question. What's your question, Lesego? You can unmute.
Will we ever get a question asking for the nominal interest?
You could be given the effective interest rate and asked to get the nominal interest, but you would just rearrange the formula. So, I mean, it's more common finding the effective, but if you had that, you've got, as long as you know this formula, all you would do is you'd move it around. So you'd start by bringing this -1 to the other side, and it would become +1. And then you'd go from there. And you just isolate this bit. Okay.
All right, thank you.
Cool. Let's try and do 7.1 first. Because this was a bit tricky. We did it in the last lesson, but we weren't all comfortable yet. So it's going to be that formula. And then we end up with 20,000 and 5. So that for me would be the subbing in. So now the question is, how do you get this I value, which is the depreciation rate? Keep those answers coming. And if you are finished with 7.1, then feel free to go on to 7.3, because that's where we're going next. And then we should have so this is going to be 0.75785. And then I'm going to use I'm going to save this. I'm just going to put this in the answer button. So I've got that. I'm going to go 1 minus answer. And we should get so, and that should be per annum. So you should put percentage per annum. So per year, you're losing 24.21% of the value of the asset. Okay. So I'm going to ask you to move. I'll leave this answer on the board, but if there's any questions, please raise your hand. But otherwise, the rest of us are moving on to 7.3, the question there.
You've got this, guys.
Do it. I'm going to take some of this out the way because it's a bit cluttered. So what do we have here? 0.12 divided by 12. 108 divided by 2. Lasedi, you can start 7.4. Yes, I am going to do 7.4 with you, even if I just do it for you. But you can start that if you are feeling comfortable. But I still just want to finish this first myself. So what do we have? We have the A and the 30,000 that starts, and we have to go through the journey of this part. We have 1 plus 2 times 12. And then we have 4 years, and it's 2 for each year. So 4 times 2. So this is what I get as my growth calculation. The green bit is over here, and then this bit is over here. And so the question is, what do we get for our final answer? I'm looking at the chat and things are looking, 58 is looking pretty common. And the answers say 58017, like you guys, yeah. So we get 58017.51 rands. That's what it's grown to. All right. What I'm going to do now is I'm going to take a moment and then I'm going to look at 7.4, and that's going to be the last question that we do today. Just before we start 7.4, I want everyone to read through 7.4 and tell me what is different about 7.4 compared to the other questions we've done so far. So take a moment, read through it, and what is a little bit different about 7.4 compared to the other ones? Shishana, let me go to you. What is a bit different about 7.4? Yeah.
So here we're dealing with a withdrawal, so money is going to be taken away from the final amount that we get.
Perfect. So basically, there's an added complexity because of the withdrawal. So what I'm going to do is just give me a thumbs up if I want to clear away the answer that I've written down. So just give me a thumbs up if I can wipe out the board and you feel comfortable that I can move on. You've taken a screenshot. Okay, because there's just too much on the board and it gets a bit confusing even for me if I have like 7 million things on here. Okay. So let's spend some quality time with this last question. The good news is it's just a slight adaptation. It's not substantially harder. It's just we have to handle the withdrawal. Okay, so if I look at this timeline, I ignore the withdrawal almost until the end. So she deposits 25,000. There's nothing new there. So 25,000. And I'm going to make this T0. Now, it says she puts it there, then she withdrew. Then she... Okay, so it feels to me like the beginning and end is T0 and T5, right? So T0 and T5 is the beginning and the end. Now what I'm going to do is I'm going to handle the withdrawal bit at the end. I'm going to leave that until later. So all I want to worry about is the other key points along the journey. So the other, yeah, Sylvanus, let me go to you. What is your question? Hello?
Can they ever ask us to withdraw money and deposit money and also the interest change?
Yeah, so they can, but it's not that bad if you just follow a very logical system. So let's just do this one together. So if you look at this one over here, I'm going to handle each of these separately, but for the moment, the 25,000 is getting all my attention. And I'm just going to worry about the interest rate changes that happen for now. So I'm going to ignore the fact that there's money that goes out and there's money that comes in. I totally am aware of that. But for the moment, all I'm going to worry about is the beginning and the end and the interest rate. So she deposited it into that at an 18% per annum compounded monthly. And then let's have a look, 25,000. Okay, so for me, would you agree with me that the interest rate doesn't change? Like I don't see, it says to me, it's 18%, okay, and it's compounded monthly. So it's going to be divided by 12. Give me a thumbs up if you agree with that. I can't see any evidence of the interest rate changing. Thumbs up? Okay, so now the next thing is, okay, there are these things about going in and going out and all that. So let's talk about the 8th. When does that occur? So she withdrew 8,000 2 years after. Okay, so I'm going to make this T2. And what I'm going to do is I'm just going to put a dotted line down and I'm going to say minus 8,000. Okay, so that's that bit over there. And then if I look at, she deposited another 4,000 into the account after 3.5 years, would you agree with me? This is T 3.5. And then what I'm going to say, I'm going to put another dotted line. This is just the way I do it. And I'm going to say plus 4,000. Okay, so now how do we handle all of this? So the way we find the final answer is we have to get the 25,000 to grow the whole way over this timeline. So the 25,000 is going to have its own little growth journey. Then the 8,000 is also going to have its own little growth journey, but it's going to be a minus. And then the 4,000 is also going to have its own little journey, where we have obviously powers up here, here, and here. Now, let's start with the 25,000. It's 5 years. And what is the interest rate? The interest rate is just going to be 0.18 divided by 12 because it never changes. What is this thing over here going to be? What is the N going to be? Okay, it's going to be 60 because it's 5 years and it's grown for that much. So I suppose I could say 5 times 12. It's probably the more accurate way to do it. Now, the problem is that's not the full story because I've pretended that I've left this 8,000 in, which I know comes out. So what I'm going to do is I'm now going to take out the 8,000, but not just the 8,000. I'm going to take out all the growing that 8,000 would have done as well. So now I'm going to go 1 plus. The interest rate is still going to be the same. Now, what is the power going to be for the 8,000? What's the number going to be for the 8,000? So it's got 3 years left to grow, and there's 12 months. So if you look at, it's got to grow from here all the way to there. So isn't it just going to be 3 times 12? So what that does is it takes out the 8,000 and it takes out all the interest because initially you pretended that it never left. Okay, last step. The 4,000 that comes in at T3.5. The interest rate is still going to be the same because at the beginning, you can see my squiggly line. Now, what is the power going to be here? So how much journey is there to go? It's just 1.5, isn't it? 1.5 years. So you go 1.5 times 12. Okay, now that is a bit of a mouthful, but the wonderful thing is it's very systematic, right? So you basically break it up into, you have the major pieces on the timeline, you have your squiggly line for the interest, and then what I do is I keep these pieces separate. So I handle them as 3 separate pieces. And so in the end, I did this question before, what you should have as your final answer is you should have 52,636.74. Now that is about as tough as it gets. But I want to, there is a practice question like this in the quiz tonight. But my hope was that I could basically just show you that timelines don't need to be super hard. You just have to be systematic about the way you lay them out. Okay, but you do need some practice. Are there any questions or comments? Because we've got time, and I'm sure there are questions. Paul, yeah, let's go to you, and then I'll go to Katlego.
Hello everyone. Hello, sir.
Hello.
Did you times the
Why did I?
Why did you times the 3 by the 12?
Why did I take the 3 by the 12? Okay. On my drawing, can you see that the 8,000 only gets taken out in the second year, and it still, in theory, would have to travel all the way from the second year to the 5th year, which is 3 years in total. And so, but because the interval is monthly, we say 3 times 12 because there's 36 months in 3 years.
Oh,
Okay, what's your question?
Hi, sir. How are you?
Very good, and you?
I'm good. I would like to ask, why is it that, okay, I have two questions. Number one is it possible if we compound the initial amount by 2 times 12? Will it be wrong?
Okay, what you can do this thing where you get to here and you then take the 8,000 out. Is that what you were thinking of doing?
Yes.
It's fine. You'll get the same answer. Okay, it's just not as, it's completely fine. You can do that. And then what you do is you let the money grow to the very end. And then you also just add a second amount for this 4,000 that came a year and a half from the end. Did you do that?
No.
Okay, so you can do it like your method. It's just you're going to basically let it grow for 2 years, then see what you've got, take out 8,000, and then let it grow for 3 more years. But remember, 4,000 Rand came in after year 3.5. So you have to add that 4,000 plus whatever interest it got to your total. Let me just get the answer. Maybe the model answer has your, I don't think it does have your way, but it might. Okay, no, it does. Okay, maybe it does have it, but I didn't copy it. But yeah, you should get approximately the same answer and it would be accepted in an exam. Yeah.
Okay. The second question is that, do I always have to compound my withdrawal?
Okay. If you leave in, so if you, can you see my 25,000? It goes for 60 months, the whole bit. The problem with doing that is I'm not allowed to do that because I should have taken the 8,000. But because I took out not just the 8,000, I took out all the interest on the 8,000, it has the same effect as if I took it out after 2 years. So it's just another method of doing it, but it's a bit neater because it says you handle each piece separately. But because you've left that 8,000 in the pot, you can't just take 8,000 out. You need to take 8,000 and the interest that it got by staying in the pot.
Okay.
Cool. All right, Level, I think if you could put the link to the quiz, guys, we've really done a lot in these 2 lessons because I really wanted to give you a proper taste of financial maths. We've got up to, the hardest questions that are possible. So I don't want you to stress, not every part of the exam is going to be like this. The majority of it will be the easier stuff, but it's good to have a sense of how this could work. All right, so if you are happy to start the quiz, the link is in the chat, but I will answer 1 or 2 more questions while students are still here. So, Kekleko, I see you have another question.
Yes.
Yeah, go ahead.
So, if I write down my answer or my method as follows, 25,000 times the 1 plus 25,000 times 1 plus 0.18 over 12 to the power of 2 times 12 minus 8,000 without compounding it.
Yeah.
And then the amount that I get,
you still have to grow. Remember, you still have to grow for 3 more years. So because you've now got up to the end of year 2, right? So let me put this in. So you've now taken the 8,000 out. Actually, wait, I'm making this a bit of a mess. So the key thing is that when you take this 8,000 out, you're not done. You still need to let it grow a little further. Can you see that? It still needs to grow for 3 more years. And so you need another part that looks like this. And 3 more years is going to be like that.
Okay.
You're still not even done because you still have to worry about the 4,000, which has to grow for 1.5 years. So it would be, now my recommended way isn't like this. It's to use what I showed initially, but it can work. So this would be 1.5 years. So a year and a half times 12 would be 18.
Mm-hmm.
That would give you the right answer.
Okay. Thank you.
Pleasure.